Okay? So phases are going to be a source of determining prediction-wise whether it's going to happen. Now, the best way to figure out is by using the charts that scientists have put together for entropy for specific values. And that's what the next problem is going to be about. Now, whenever we talked about delta before, we always said that this is going to be products minus reactants. So that means we're going to have 2 times whatever the NaCl solid is, minus the sum of the reactants. So minus 2 times sodium solid. It is possible to have sodium liquid. I've worked with it. It was kind of fun. Plus chlorine gas. Okay? So let's look those values up. Now, I'm going to use the chart on page 812. Hopefully they've got all the numbers in there. Sodium is over on the left-hand side. They kind of got it classified by group numbers, which is silly. Alphabetical order would have been so much better. But we've got 2 NaCl's here, solid, and that's 2 times 72.1, minus 2 times sodium solid, so it's 2 times 54.1. Oh, 51.4, I'm sorry. 51.4 plus, in just 1 chlorine, and chlorine gas is 223.0. So, I'm going to go ahead and get my trusty calculator and do this work. So 2 times 72.1 minus parenthesis 2 times 51.4 plus 223.0, close parentheses, enter, and I get negative 323.7. Well, we'll just say 324, round off to 368. Now the label for this is joules per mole Kelvin, or just plain joules per mole. Either one is acceptable. If you get a negative value, that means that this is going to be more ordered or less disordered. And you can see, you started here with 2 solids and a gas, and just get 2 solids, no gas over here, so this is much more ordered, less disorganized. So this is going to be as we would predict. Negative is what we would have predicted, like we did in the last problem. Now we do the same thing over here. Our delta S value starts with our products minus reactants. So this is going to be 2 times whatever CO2 gas is, plus 4 times whatever H2O gas is, also known as steam, minus, and now we go over here, 2, this is methanol, so 2 times whatever methanol liquid is, plus 3 times oxygen. This is O2 gas. All right, so we go back to that chart on page 812, find the CO2. CO2 gas is 213.7. H2O gas, also known as steam, is 188.7. 2 times the methanol. It's over there on the left-hand side, 127. Wait, this is, yeah, that's the liquid, 127. and 3 times oxygen, pure oxygen here, oxygen is a gas, so it should be fairly high, yep, 205.0. Remember, the more it is towards the disordered, the higher the value is going to be, so it makes sense that oxygen would be pretty high. So again, we go back to our calculators, and we get 2 times, parentheses, 2 times 213.7 plus 4 times 188.7, close parenthesis, minus parenthesis, 2 times 127 plus 3 times 205.0, close parenthesis, and see that I made okay. So yeah, 313 round up to 3 sig figs, joules per mole, Kelvin, possibly put in there. What's the chart say? Yeah, joules per mole Kelvin, so it should have a K in there. All right, so it's a positive value, which makes sense because we got 2 liquids and 3 gases. We got 6 gases over there. So we'd expect increased disorder. So that is positive. Now, the next one's kind of the same thing. Predict the sign and then find the actual sign for this. So let's take a look. We got 3 gases here, and we got 1 gas and 2 liquids there. So this is more ordered. So since this is 3 gases here, and we got 1 gas here and 2 liquids here, we are going to anticipate a negative delta S. That's the anticipation, that's the guess. Now we're actually going to find it. So we go back up there, products minus reactants. So this is going to have 1 CO2 plus 2 times whatever the water is. That's H2O liquid. Close parenthesis, minus now the reactants. 1 CH4 plus 2 oxygens. It's a O2 gas. And this is CH4 gas. Really need to put the phases in because, like I said, they have multi-phases for the same substance. So, go back to the chart on page 812. Let's find these values. We have CO2, carbon dioxide, and that is 213.7. And we've got 2 waters. That's going to be oxygen, water, liquid, 69.9. CH4 goes into the carbon part. CH4 is on the left-hand column, 186.1. And 2 times, or 2 liquid waters. Maybe it's 69, I did it wrong. Yeah, no, it's 2 oxygens. 2 oxygens, okay. Almost screwed that one up. 205.0. Okay, now, get our calculators and see if our prediction holds true. Okay, so we've got parentheses 213.7 plus 2 times 69.9 minus, when we go to the reaction side, parenthesis 186.1 plus 2 times 205.0. Close parenthesis, and oh my God, I must have punched in something else. Let me see what we did. Oh, we got 2 plus signs, so that's kind of dumb. Try that again. Negative 243 joules per mole Kelvin. And sure enough, it's negative like we anticipated. So that's how that's done. Your practice problems. (32 to 36) even on page 833. Have fun.